Okay, I have finally received my e-bike battery case for my 48 volt e-bike. Took almost 2 months of shipping to get this. I ordered it from AliExpress. Cost about $30 for the case and everything, but I wanted to, I want to try and build a professional looking battery, so that's why I decided to order, the case. But here it is. I haven't even opened it. Let's just see what we have here. This is a 48 volt. It is a 13S by 5P design. Here are the holders. You will have to figure out how those configure in there. Here is the underside of the battery. Okay, yeah, that's pretty cool. There's like a power meter on the side here, so that's pretty cool. There is this lock here. Now, originally I actually thought the key, if I'm being honest, I thought the key turned on and off the electrical pack. I thought the key actually turned on like a mechanical switch, but there is no electronics around this. So this does not turn on and off the electronics. And I see now what it does is there's a railing system underneath, and when it's locked, this railing is locked in, and then when you unlock it, the railing system comes loose. So this is so that you can bolt this to your bike and then just slot the case in onto the bike. Whenever you need to, you can take it off for charging and plug it back in. There we go. Okay, so so that just locks on and off the railing system. On this side we have a charge port and a switch. But I have to say, this switch is pretty tiny. If I don't know what I'm going to do with this switch, because I can't exactly use this switch to turn on the main pack. Since there's no ways I can run like 15 amps or anything through this little tiny switch. And so I don't know what I'm going to use that switch for, because, I just don't know what I want to, what can I possibly turn on and off with this tiny little switch. So we will have to figure out a switching system. It is possible that there will be no switch, that I will have no switch on this battery. Because the e-bike motor and stuff itself has its own switch to turn on and off the motor. So and this can be removed for charging, and obviously it'll be electrically disconnected when you remove it. So I just don't know if there will be a switch. It's unfortunate. This is just a tiny switch. I don't know. I'll have to see what they think they rated the switch for, but I don't know. Anyways, so that's the switch. There's a barrel connector for charging, so that's cool. We'll put that to the BMS and charge. And then these pins here, and when I first saw the pictures, it took me a second to understand what these are. This is where you're going to connect your main positive and main negative to these, and the reason is you want to be able to remove the pack from the bike, and if you had wiring and stuff coming out of the pack, then you would be unable to remove the pack from the bike. Well, this you can see the railing system here locks. These pins slide into these grooves, and the electrical energy then travels through these pins out the bottom here, and you can have electrical wiring coming in the bottom here. So this is on your bike, always wired up, and the wiring goes in here, and then you can lift out the battery when you need to and put the battery back when you want to ride, and then it just locks in, and then the energy will travel out through the base there. So that's interesting. They've given you 5 pins. I'm not sure what I'm going to do with the 5 pins. I guess I could wire like a headlight or something and use the switch for you know, like a headlight or something like that, for some auxiliary power or something like that. That's doable, that's possible. But anyways, let's have a look at these holders. This is the main reason I bought this. You know, these are going to hold 65 batteries in a 13S 5P configuration. I actually downloaded a cheat sheet. This was with on the you know, with this case was this cheat sheet on how to put the batteries in, which will be helpful. Now the reason there is actually a reason they don't just make, you know, a row of 5 and then another row of 5 and another row of 5 and another row of 5. There is a reason they don't do that. By just doing a single row of 5, you would only be able to put a single row of nickel across it, and nickel does not carry that much current. So by doing these star patterns and joining the star patterns to each other, it means there are multiple nickel strips going between the packs of 5s, and that, you know, doubles and triples the current carrying capacity by using more nickel joining the various, you know, bunches of 5 cells. So that's why they use the star configuration. So I think I will use the star configuration as well. You know, might as well try and have a little more current carrying capacity. But actually, you know, it took me a sec, you know, looking at this, you know, it's hard to, my first impression is I don't even know which way these things go in here, but obviously I guess it can't go this way because this will run into that. So it almost has to go in this configuration here, which I guess works, and then this, you know, comes on like that if I don't knock everything over, and then you'll have your e-bike like that. So yeah, I think I'm excited. I think, you know, yeah, that is a nice looking battery case when it's all buttoned up. So I think I'm gonna configure, I'm gonna start to lay out the batteries in some sort of star configuration similar to this, and then we'll see what it looks like. Okay, I have configured the batteries kind of how it is shown on the picture. Honestly, this picture is pretty difficult to read, and it's kind of reversed and upside down from the way you're looking at it. And if you look at it here, I mean, this looks like kind of a mess. It looks like a big pack of cells there, and a big pack of cells there, and a big pack of cells there. But actually, that's not how it's configured. It kind of does a thing like this around and then back again for the 13 packs. So if you sort of look at it like this, now it looks more like a pack of 5, 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 and then there's a pack of 5. Here's a pack of 5, 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 and then here's a pack of 5. The only one that's weird is, and you can actually see it in this picture here, is this first one. There's just sort of a single cell out in the corner there. So we'll, you know, that single, which is actually this, which is this pack over here. This cell will technically only have a single connection of nickel to it, which, you know, could, you know, that's a little, you know, wish it had double nickel on it, but maybe I'll just put a second strip of nickel just to make sure that it's got the current carrying capacity of everybody else, because everybody else is now going to have, you know, zigzag nickel. So all right, I mean, here is the pack configured. I am tempted to jump right in and just start you know, laying nickel, so maybe I will. Okay, I'm gonna start doing some spot welding here. I'm using my good old $11 spot welder over here, and just for fun, I've just actually, these are my normal needles. This is another spot welding pen I got to try, and I have not used it yet. For fun, I'm gonna give it a go here, see how it does. But in the meantime, let me turn on the spot welder here. Okay, we are in spot welding mode. Let's take one of these slightly longer strips. I'm gonna make this my main negative. So let's lay down a piece of nickel and let's see how this this new spot welding pen works. Might be okay. This is 0.12 nickel. So thicker than the 0.1, but not quite as thick as 0.15. So, you know, I haven't spot welded this 0.12 before, so I'm just trying it out and see how it goes. Seems okay. Let me see if I can lift this nickel off. And let's just make sure that this nickel really is on there. Yeah, it's pretty much on there. I guess I'll rip this off now. Yeah, that's pretty good. I'm pretty happy with that. Now I've got to clean up some of these boogers. Yeah, that's all right. I think I will use that. I do feel like though I had better penetration with my regular needles. So I'm going to switch back to my regular needles and do another strip, and then we'll see if the regular needles do any better. Okay, let's put back my regular needles. Let's try do that again. Okay, that is that. Now, actually, I need to be careful about how long I left this nickel. See how close it is to the next battery. You know, when I start working on this battery, and this battery is connected, you know, if that sort of overhang could cause a problem. And actually, so ideally, I should try fold it up and cut it off. And I need to be more cognizant there. I need to be more. There we go. Okay, so now we will need to make some zigzag joins here. Now this is the hard part because, you know, this battery is kind of on its own. I can make a little one here, but now I'm going to end up with 3 layers of nickel on here. Now let me see how much nickel I need for this. Pretty short. Oh, cut that way too short. Yeah, that's terrible. We got to do that again. Now be careful when you cut nickel like this. The rest of this battery is not yet connected, but when I start working on the other side, if the back was connected and a piece of nickel fell between these 2 batteries, it would instantly short out the system. So I actually do recommend you start to use Kapton tape. As the pack starts to come together, I do recommend you use Kapton tape because once you start to make the series connections, these batteries start to become live. Alright, I'm happy with that. That laid down pretty nicely. Okay, I am happy with, oh shit. Yeah, don't do what I just did, which is probably, yeah, I must have shorted, this is the positive lead, I must have shorted with the negative on the battery. Don't do that. You know, probably be a good idea to wrap this in Kapton tape too, since, you know, whenever you drop the needles. Now, the real thing that I'm a little worried about here is that here I have to spot weld through triple nickel, and that's going to be a challenge for the little spot welder. I'm not worried about double nickel. Okay, let's be careful and put that down over there. See, that needle just wants to. Okay. Yeah, that is. Yeah, I guess that is all right. Every battery has, you know, sort of at least two connections. Yeah, this isn't bad for a you know, $11 spot welder, and I think it's going to be helpful if I take some more accurate measurements of the nickel strip length I need, and I pre-cut some so I can get neater connections. But yeah, I think that's the start of the battery, so I think I'll continue, and maybe I'll time lapse you, or maybe I'll just come back once it's done. You know, one thing to remember is I could go around and spot weld each of the 5 batteries together, but then I still have to make the series connections between the packs, and that's nickel on top of nickel on top of nickel. So it just occurred to me, now is the time I need to use nickel across the entire, you know, I need to use one piece of nickel and make the series connections as the same time as I complete each of the 5 packs. So this, you know, and this, and then I can use some parallels to finish out, you know, these, and that'll complete the series connections and build the 5 cells in a parallel pack. Okay, well, I'm nearly done with the pack, but actually I've actually paused because I think either the battery or the spot welder is starting to overheat. Although the spot welder is not particularly warm, I'm starting to get misfires where it beeps but nothing actually spot welds, and So it's time to take a break. The battery is warm, but not too hot. I'm interested to see what the voltage on it is, since I've been spot welding most of this pack. Obviously it started at almost 4.2. Let's see where we're at. Let's try not to short this out. So we're down to 11.74 from 12.6. So the battery is still fine. It's not even at its like storage charge yet. But probably time to, take a break. Anyways, I think I'll probably end the video here. I'll finish this battery out. And then the next video, we'll start the wiring, put a BMS in, and figure out how we're going to configure it in the case and if I'm going to do a switch. And we'll probably do that in the next video. Anyways, hope you enjoyed. And if you like, please hit the like button and subscribe. Well, I almost finished. I have one more section of series connections to make, almost finished, but I blew the MOSFETs out of the Spot Welder. The poor Spot Welder. It almost, it made it over quite a few spot welds, and we're definitely, I'm pushing, this is capable of, I think, 400 amps. So we're definitely sort of outside of its factory certification range here, but yeah, we blew the MOSFETs to hell. So anyways, guess I'll have to try and Amazon in one of these so I can finish up this battery. But yeah, almost made the thing. Not the neatest spot welds I've ever done. Sometimes the zigzagging pattern got a little confusing and didn't always line up right. But we're almost there. So yeah, well, we'll say a prayer for the spot welder and get another one.